These are just some of the parts that are made here. Though they are manufactured precisely the same as those that have preceded them, the parts are still unique. Each has a specific number and was built to meet a specific order. And that's true of this part. And this part. All of the parts made here and in other factories, like this one in Canada, or this one in Cleveland. And they all come together at Renton, Washington, to become a part of one particular Boeing customer's airplane. Whether it's a 737, 727, or 707. The airplane that comes out of those doors was actually started more than 2 years ago. That's the time necessary for ordering some of the materials and parts used in its fabrication. Materials that must be tested, weighed, judged, to find just the right one for the job, the lightest and the strongest. New materials, new designs, new parts, all had to be timed to meet a precise deadline to make sure that assembly of the airplane would not be interrupted or delayed. Whether it's a 737, 707, or 727, the basic steps in the assembly process are essentially the same. All of the pieces or parts, more than 1 million in the 727-200, are assembled into larger pieces. The largest of these are called sections. Every section, every part is identified by a number which indicates just where it belongs on the airplane, and frequently what specific customer airplane it belongs on. Carpeting is cut to order. Silkscreen panels must meet the customer's precise requirements. And they must be the same, time after time. Bundles of electric wire are made up with wire that is both color-coded and numerically tagged in order to pinpoint the exact area where each inch of the 45 miles of wire will be used. This machine is a time-saving invention. It measures, cuts, and imprints a part number in one rapid operation. At Boeing, manufacturing techniques are always being analyzed and evaluated to find if there is a better way, a more economical way to do the job. This results in new tools, new procedures, a product that is constantly being upgraded. Development and use of new materials has resulted in a more durable insulation that is now standard for electrical and electronic systems. The result is less need for maintenance and increased service life, a better product. This tool shows the exact termination point for one wire in a bundle of wires, a task which used to require a manual search and check of each wire. This new way saves time, reduces errors, keeps production costs down. Every strand of wire, every connection, is inspected and tested. You'll see this control panel again in the final assembly area, where the streams of parts and sub-assemblies flow together to form the final product. And each item must arrive at the proper place at the proper time. While wiring, tubing, interior panels, and other items are being fabricated to order. The larger sections are also being assembled. This kind of manufacturing demands a highly skilled workforce. The precision required is evident when it comes time to join the major sections. Assembly time required for the 5 major sections of the fuselage varies. The control cabin that will house the panel being assembled in the wiring shop is taking shape in this assembly area. The shape of the cab makes it easy to identify, but note the number on the top of the cab. Even at this early stage, each section is unique in one detail or another. The familiar 727 tail section is built up piece by piece in this area. The engine mounts, the fin and exterior skins, the external and internal components of this 30-foot high structure are assembled and ready to be painted and coated with a special sealant and then moved to final assembly, a move that usually takes place at night. This minimizes any possible disruption of the normal work pattern. Assembly of the wing, the largest single section, involves 5 different steps, and the wing, more than any other section, shows the changes, the improvements, the constant refinement the 727 has undergone. Although the basic shape of the wing has not changed, static and fatigue strength has been increased. The pieces to be joined, the stiffeners, cords, ribs, skins, spars, all of the components are different than on earlier 727s. They have been beefed up. They are stronger. There have been changes in the methods of assembly, too. Fasteners used to be installed by hand. Now this machine, called a drive-matic, does the job automatically. It saves time, produces greater uniformity, and thereby extends the service life of the wing. By combining new materials, new design, and new assembly techniques, the 727 will fly in excess of 20 years with normal maintenance. After being sealed, the upper and lower wing panels are joined to the major part of the wing with the front and rear spar and ribs. This is the attachment base for the leading and trailing edges, the wingtip, the landing gear beam, and other sub-assemblies. Fuel tanks are a part of the wing. After painting, sealing, and pressure testing, the wings are ready to be joined with the center section. The center section floats in the assembly jig so that it can be aligned with the rigidly held wing. This join area, the major part of the wing to the center section, is subject to the greatest flex in flight. Because of this, the closest possible tolerances are adhered to. Quality control is very strict. It takes more than 1,200 fasteners, rivets, lock bolts, high locks of varying sizes to complete the join. The wing center section also serves as a fuel tank. In addition, auxiliary fuel tanks can be installed in the body if extra capacity is needed, another variable that makes each 727 unique. This is also the point where flap tracks, spoilers, ailerons, electrical control wiring, and other detail installations take place. Now the major sections are ready to be joined. First, the tail section is prepared to join the aft body section. Mounted in a special tool, the 2 sections are mated and fastened with approximately 1 bolt every 2.5 inches. Next, interior attach points for plumbing, galleys, electrical wiring, lavatories, and so forth are made. Exterior windows, thermal insulation, aft entry door, center engine air inlet, and other installations take place in this area. Meanwhile, the control cabin and the forward part of the passenger cabin are also being joined. Again, in the interior, the electrical and plumbing attach points, the seat tracks, insulation, and so forth are being installed, normally starting forward and working aft. The final items are usually the nose gear and electrical hookups. The next step is an important one. It's time to give our bird its wings. Time to join the fuselage to the sealed and pressure-tested wing. There are 4 main attach points where these sections meet. 4 points where tolerances are so critical, the fit so precise, that all work in the airplane stops. No one is allowed inside while the 4 attachment pins and bushings are being inserted. The bushings are shrunk by soaking in liquid nitrogen at more than 320 degrees below zero for 30 minutes. After insertion, the bushing will expand to make an exact fit. Tolerances are so precise that the bottle pin can be inserted with little effort. Now the rest of the crew can move in and complete joining the fuselage to the wing center section, while the leading edge slats, stabilizer, wiring, control cables, and other installations take place. In this location, the forward part of the fuselage is joined to the wing and the aft fuselage sections. Interior installations continue. The main landing gear is installed, and the airplane is lowered to the ground for the first time. Now it can be rolled forward to the next workstation. Here, flaps are installed and testing begins. The cargo compartment is lined, Air conditioning equipment goes in, and support structure for interior panels. And cockpit panels are installed before the airplane is moved to another building where the airplane systems will be completed. Here, the airplane will take on a look familiar to passengers around the world. The interior rapidly takes on a familiar look. Galleys, overhead stowage, panels, dividers, carpets, seats. While these passenger cabin details are being handcrafted, the control cabin panels are being adjusted. Cables are checked. Landing gears cycled. Stabilizers and flaps are tested to make certain their movement is coordinated with the proper control position. Specifications are first met independently and then as an integrated system. All functional tests must pass rigid standards. The last items installed are the engines. The airplane is inspected and accepted by the customer. All that remains is to paint on the customer's colors. But even without them, this is an airplane that would be recognized at any of the free world's airports. Between rollout and first flight, all the vital pre-flight functional tests take place. Fuel system check, electronics check, auxiliary power unit, engine trim and performance, pre-flight testing and tuning. Implementation to delivery of this airplane took approximately 11 months. But the material for this part had to be ordered 30 months ago, long before the assembly process began. These were ordered 17 months ago. Yes, we at Boeing know how to put the pieces together. More than half the commercial jets in world service prove that fact. And we know that each airplane made is, in one way or another, different.